Hello. You can see by the time that it's kind of late, and that is kind of like what's gonna happen now with these episodes when I'm working these two jobs. I have to come home, eat some dinner, usually at either, what's there, or cook, and then go to the gym, and shower, and then after that, I finally get to do my studying. And today I watched a movie with someone, so we didn't get to this episode until late tonight, and I just finished my LDAP, the directory or lightweight directory access protocol. I just finished my session on that, and I'm going back in time now to review this session for the video. So yeah, I'm gonna be a little bit more tired in these episodes from now on because a lot of it's gonna be working at night, and then I gotta literally get up early the next morning for either one of my jobs. And so yeah, so a lot of these videos are going to be published at night now. I've got a lot on the schedule, but we're going to get to it. Definitely got two more videos coming to you guys soon. I might be able to record both of them now, but so day 34 was really about DNS. So we're doing the thing where we're running like the port scans, we're seeing the different ports, and now we're actually going into each port. And so we're kind of moving away from DNS just being that, oh, we have an IP address and we want to configure that to google.com. We're not making us not having to remember IP addresses. We're moving into that being a enumeration target. Now, before we get into our episode, I want to thank you guys so much for the subscribers. I'm not 9 subscribers, which is pretty cool. And I want to thank Ghost, I'm just gonna pronounce it Ghost BMO. The Adventure Time profile picture is pretty cool, my friend. Um, I love that show as a kid, but I want to thank you for commenting on the congratulations for my job, and then also you people down here as well that gave comments. I want to just thank you as well for your comments, and I also want to thank you for the views on this video. That's pretty good. So let's actually get into the session. So for those of you who have been here with the channel, you know that I am studying for the Security Plus exam, CompTIA Security Plus. I want to take it in around October. So we did a little lesson on hashing versus encryption versus encoding versus digital signatures. So encryption protects data so unauthorized parties cannot understand it. And the basic idea is you have a readable plain text, and then you have encryption plus the key, and that creates the ciphertext. Now, authorized parties, so people who, have the key or the method, they're going to use that process or that key to recover the plain text. And encryption is reversible when you possess whatever is in store. So the whole point of it is confidentiality. Only those who are allowed to see that information are the ones that are going to be seeing it. Now, hashing is a bit different. Hashing is where you take a hash function and it takes input and it will produce a fixed size output. So you have your input and then it gets run through a hash function, which will then generate a hash value. Now, you don't decrypt a hash back into the original input. So encryption does not equal hashing. So like basically when you hash something, you can't dehash it. The only way you'd be able to do it is if you hash the same words and then they generate the same hash and okay, that would be the password. So it has a lot of useful purposes such as integrity checking, password storage systems, and file verification. Because you put a file through a hash function, okay, so if you put that file through the hash function again and it's the same exact thing, the file was not modified at all. So hashing a password does not make weak passwords magically safe, and I just said there they can still guess the passwords, hash the guesses, and compare the results. So because of what I mentioned about hashing, there's things called salting and peppering. I'm not going to go over peppering in this video, but we will go over salting. So a salt is like random data incorporated into password hashing. So people could have the same password, which is the issue I just talked about. So let's say people both have the same password called bear123 exclamation mark. Without salting, these inputs are going to lead to stored password hash outputs under the same hashing scheme. So with salts, you have this salt A and salt B, and it will result in two different hashes. Encoding, so encoding really isn't security by itself, it will change data representation so another system or process can interpret or transport it. So something can be converted to base 64, and someone who understands that encoding can just decode it. So it's not the same as something being encrypted. I know people tend to mix those up. Encoded really doesn't have much to do with any of that. Digital signatures. Sorry about that. Just it's almost 12 a.m. and I've been up since the morning. I'm pretty tired, but we're gonna keep going. So digital signatures. So we went over the concept of non-repudiation, I believe, in Security Plus Lesson 2, and that's where like you do something and there's systems in place where you can't try and get away with it. There's just overall process, a tracking process of who did what. So a digital signature is designed to help establish authenticity, integrity, and evidence associated with a signing identity. You basically have data, a cryptographic signing operation, and digital signature, and then the recipient is going to verify, okay, was it altered, was it signed using the expected key. So okay, so I'm trying to think if there's anything I need to update any of you viewers on in terms of my progress. I've been doing the IT job for 2 days now, and a lot of similar problems coming up working with Wi-Fi issues. A bit of hardware, multi-factor authentication, but it's pretty cool so far. I like it. I like the job, which is good because I want to like the job, and I'm not saying this because like, oh yeah, like I'm like I actually like the job. Like it's something I'd consider doing for a while, even if I wasn't being paid well. So phase one, so we're just doing a little bit of recall of what DNS actually is. So what problem does DNS solve? It fixes the problems of finding computers and services by name instead of having to know the IP addresses, which I talked about with my google.com example. What does an A record do? So an A record maps a host name to an IPv4 address. So for example, you have srvdco1 kevinlab.local and it maps to this IPv4 address. An SRV record just basically tells a computer where a specific service is located on a network. So an SRV record is just service and it's at this server plus port. Why does client O1 have to use SRV DCO1 as DNS? We've talked about this a lot, but client O1 needs DNS that knows about the Active Directory domain, and SRVDCO1 posts that DNS information that allows it to find it for authentication services such as Kerberos. It's good for lightweight, well, LDAP, which will be the next video after this. What does this long thing mean? Well, this is actually a DNS SRV record, and it's the name Active Directory clients use to find a domain controller that provides LDAP for the domain. Because you can see here, okay, we're looking for LDAP over TCP, domain controller, I believe. This is some Microsoft service. I forget the name of it, but yeah, and then this is the domain name. It's very long. I don't have this memorized. Hopefully in the future, as I do more work with it, I can kind of get it more familiarized. And then why did being able to ping DC not prove client on one's AD configuration was correct? Pinging just proved connectivity. It doesn't have anything to do with actually like the configuration of Active Directory. So DNS as an assessor. So this is like kind of like theory before I actually get into the work. That's kind of like what I've moved into, like trying to understand, okay, what it is, then doing a practical. So DNS can help an assessor map infrastructure. It can reveal different things. That can reveal host names, IP addresses, domain controllers, mail systems, service locations, Kerberos services, LDAP services, global catalog systems. So when I do an Nmap port scan, right, and I see, okay, 53 slash TCP open, the question becomes, what does this DNS server know about the environment? So we are going to meet Dig, and Dig is a DNS query tool on the Kali virtual machine that I have. And so the structure of the command is you type dig and then the DNS server, which would be the IP address of our domain controller, the name of the domain, so kevinlab.local, and then the record type we want. So in this case, we're looking for A. So a breakdown of this command. So dig is just the tool we mentioned. This is the DNS server that we're asking about. This is the name being queried and the record type being requested. So you want to understand dig output, you need to know there's different sections. There's a question section. What did we ask? There's an answer. What answer did the DNS server return? There's a server, which DNS server gave us a response, and then there's flags like such as did the query succeed, was it authoritative, and was recursion involved. So we're doing our practical. So instead of like these episodes being too long where I'm like setting up the virtual machine, I'm trying to include screenshots now. I think this will be really easy for you guys if you want to study along with me. You can use my GitHub and see my screenshots instead of having to watch these very long episodes and trying to follow my scattered stuff. So if you come over here to GitHub, the link is right here. So you can find me on GitHub at Scared Say Kevin, and you can come into notes. We're currently in phase 2. So I have these uncategorized notes, and this is all my preliminary work and all of the Active Directory. You just need to follow this. So we start at day 1, and this isn't the actual first project. This is just me learning on the first day and everything I did there. And you can see that, I've come a long way. And so knowledge is also the master review of days 1 to 30. I had ChatGPT make this just a bunch of questions to test yourself, make you interview ready. If you can answer all this, you understand everything for sure. And then, so if you want to follow along with me for phase 2, I only have 5 documents so far. And so like day 31 goes over the beginning, our first security plus lesson. But let's say you want to follow along with day 34, you come here and then you have these screenshots and the commands that I use for you to follow along on your own. The only thing you have to do is like um downloads, like get the virtual machines, and if you're lost, we're in the age of AI. You can ask AI how to find anything. I use AI in my day-to-day life for schedule making and a lot of stuff. I always have it open here on the taskbar because it's just really helpful and assists with a lot of things. So if you're having any trouble following along, if you do want to follow along, just use the AI and have it guide you. Don't let it give you the answers. You want to find the answers on your own, but have it teach you things, theory, have it guide you, but you have to put in the work yourself, which is what I learned the hard way, um, with coding especially. So we're going to be basically enumerating Active Directory DNS. So our authorized target is the server, and basic domain query is part 1, and the goal is, can the ADDNS server provide information about its own domain? So right here, we're just testing connectivity. We have the Nmap scan specifically on port 53 and service detection, and you can see that, okay, we have connectivity. And then we try the first dig command, and we have a lot of different things here. But in this line where it says header and it says status no error means the DNS query worked. I think that's the only thing you really need to focus on. A lot of this is just like jumbo mumbo mongo BS, and I don't know what it means myself. So you don't need to stress over it. You just need to keep working with it, and everything will keep making sense. So you can see we have different flags here. QR is response to a query. AA is an authoritative answer. RD means recursion was requested, and RA means the server actually supports recursion. So in the answer section, you can see that kevinlab.local and then 600 in A 192.168.1.236. So you read this as kevinlab.local resolves to that, and then kevinlab.local is the name, and 600 is the time to live, and blah blah blah. You don't need to worry about too much. Just kind of try and understand the overall theory. Don't go too deep into every single thing because you're gonna forget a lot. You're gonna have to come back and review, and I think it's good to review the tip of the iceberg and then specialize later. Especially because I'm not specialized in any of this yet. Um, so part 2 is domain controller discovery. And now query the SRV record I have seen since phase 1. And that's the SRV record we're talking about. So we've changed up the command a little bit. This is what we're querying now. And we've changed the record to server because we're working with this. And This command means ask DNS server, the domain controller, which server provides LDAP domain controller service for kevinlab.local. And you can see in the answer section, it's in, you can see it's, so 600 time live. So this, right here, it's in srvdco1.kevinlab.local. So the domain controller providing LDAP over TCP is srvdco1.kevinlab.local on port 389. That's what all that means. It looks like this looks confusing at first. You just need to kind of focus on what's important to us. That's why it's important you can give these screenshots to AI if you don't understand it, have it explain it to you. And I think that's a good means of learning if you're lost. So part 3, we have Kerberos service discovery. So we know Kerberos exists in AD and server records advertise services. So the DNS name follows. So the goal is to query for domain Kerberos service. Can DNS tell an assessor where it exists? So it's kind of the same thing we did here. We want to change that server record to now Kerberos on TCP in kevinlab.local. And we can see in the answer section that it provides it. That's all you need to look at. Don't make it too complicated. Now, part 4, we want to resolve discovered host. So the server gave us the host name that, and now we want to query its A record. So the chain is you have the domain, you have service discovery, you find the server host name, and you want to find its IP address. So you're gonna dig at 192.168.1, blah blah blah, and it gives you its IP address. Now obviously we've been looking at it the whole time because we know beforehand. But let's say you are assessing the system, you wouldn't know that beforehand, and you query the A record to get the IP address. In part 5, we wanted to test a DNS zone transfer. So DNS servers sometimes need to replicate zone information between authorized DNS servers. A zone transfer can copy records from one DNS server to another. So imagine an arbitrary network client could request that. Give me every DNS record for kevinlab.local. That would be pretty bad if an attacker got its hands on that. So as an assessor, we're going to test whether a zone transfer is improperly allowed. So the record type, it's called AXFR. So where we've had the A record and the SRV, we're gonna replace it with this AXFR. So we're gonna use dig. The server is the same. The zone is kevinlab.local, and we type that command. And obviously the transfer failed, that's good. We don't want, because there's no authentication being done here. We're just on a different network client that should not be allowed. So it's good that it failed. So that is all I have for the DNS enumeration. If you guys have any questions, let me know. I think I can bang out the LDAP video right now as well. So you should be seeing that after you watch this. If you want to just jump into that right after, be my guest or watch it another time. But yeah, that's the end of this episode. Just want to thank you guys so much for watching. If you have any questions, put them in the comments. Message me on any of my emails, LinkedIn, just anywhere. And yeah, I'm always open to talk about opportunities, advice, or any potential projects that you may want to collaborate or recommend to me. Thank you so much for watching, and I'll see you in the next episode. Bye.